All right, Model 2, Section 10, Objective 1. And for this particular class, we are on 2C because it's Cohort 3. Okay, so adding fractions. First off, a visual model. Okay, these are called fraction strips. And let me explain how to use them, what to do, and all that kind of stuff. If you notice, each one of these different colored rectangles is the same size, right? But each one is broken into a different number of pieces, and the number of pieces is the same as the denominator. Okay, so the fourths, there are 4. The fifths, there are 5. The eighths have 8, etc. So in other words, it takes 4 fourths added up to make 1. So what you actually do is 1/4 plus 1/4 plus 1/4. This is really messy writing, sorry. Plus 1/4 is 4/4, which is 1. Do the same thing with fifths or sixths or eighths or tenths or anything. Okay? Like 1/2, there are 2 of them. So 1/2 plus 1/2 equals 2/2, and therefore it's also equal to 1. Okay? So that's the first thing. The second thing is you can rewrite certain fractions using other fractions. So for example, here we go. So 1/2 is here, right? If I continue that line straight down, you can see it continues to the fourths, and it continues to the sixths and the eighths and the tenths and the twelfths, but it doesn't on the fifths or the thirds. Okay, so I have a better image of that on the next screen. Hang on. Okay, so I have that thick black line drawn at 1/2 all the way down. Okay, so here on the thirds, it doesn't go through one of these separation lines. It goes right through the middle of this section. So that one we can't do. This one, however, because it goes right through the line between this one and this one, we can rewrite 1/2 as 2/4. Okay, so 2/4 is acceptable. And these are called equivalent fractions that we covered at the beginning of Unit 2. Okay, so for example on this one, if I times 2 by 2 to get 4, I have to times the 1 by 2 to get the 2. So whatever you do to the bottom, you have to do to the top. So 2/4 is equivalent to 1/2. It's equal, the values are equal, but because you write it a different way, they call them equivalent instead. Okay, so we've already talked about 1/3 cannot be written because the line goes in between the middle of this one block. Fourths can be done. We did this one. Okay, fifths, it goes in the middle of the block, so that does not work. But we can do sixths, okay, because it goes right in between these two blocks. So we can do 6. Let's go off to the side now, and 6. Okay, what do you times 2 by to get 6? 3. So if you times the top by 3, you get 3. And if we look over here, sure enough, there are 3/6 before you get to that line. Okay, so without doing all of this calculation now, you can just look at this chart, which makes it easy. But you're not going to have a chart on your exam, so knowing this red and blue stuff off here to the side is incredibly helpful. Okay, can we do eighths? Yes. Okay, so eighths over on the side. How many eighths are there between this end and 1/2? There's 1, 2, 3, 4 of them. So it is 4/8. Can we do tenths? Yes, because it's right in between. So 10 And how many tenths? 1, 2, 3, 4, 5 before we get there. So it's 5. Twelfths? Yep, we can. So 12 becomes our denominator, and 1, 2, 3, 4, 5, 6. 6 twelfths. Okay? And there are extras there because this chart doesn't have to end on 12. It can keep going forever. Okay, so this chart can continue going down forever. We can do hundreds, we can do 5,000s, we can do how many ever pieces you want to draw. But we stop here because that's what the graphic stopped at. Okay, so for example, if I had 20, that would mean I would have 20 pieces lined up together to give me 1. They would be smaller than these because you need 20 of them instead of 12. Okay, and I times 2 by 10 to get to 20. So I times 1 by 10 and I'd get 10. There would be 10 on the front of the line, that vertical line, and there'd be 10 on the back of it. Okay, so fractions. Here we go. Let's continue. Here's another chart that is very similar to that first one. It's just not colored. Okay, this is more like what you see in your notes. And I've added 2 vertical lines in there. So the red one is where? Okay, it's right after 1/3. Now I say after because it's reading from left to right. So we start here and we go across. So it's after 1/3. This is after 1/2, like the first page. Okay, so after 1/3 is here. Okay, so can I write it as fourths? No. Can I write it as fifths? No. Can I write it as sixths? Yes. Okay, so if I put 6 over here, whoa, let's try this again. I've got to rearrange for a second. Hang on. Okay, sorry for the shift. Okay, so if I'm writing 1/3 using sixths, I have, there's 1, there's 2. So I have 2 sixths before I get to the 1/3 line, that red line. Okay, can I do sevenths? No. Can I do eighths? No. Can I do ninths? Yes. Okay, so ninths. And how many ninths? 1, 2, 3. What's the other one that we can do on here? It would be twelfths, right? We have 1, 2, 3, 4. Okay, that's just using this chart to come up with the answers, not doing equivalent fractions. Okay, so now let me clean up inside the chart because now we're going to look at the blue line. Okay, so the blue line is over here at the line in between these two. So I'm going to do 1, 2, 3, and they're fourths. So it's 3/4. Okay, so can I do fifths? No. Can I do sixths? No. Sevenths? No. Eighths? Yes. Okay, so the denominator is going to be 8. And how many do I have? 1, 2, 3, 4, 6. Can I do ninths? No. Tenths? No. 11ths? No. 12ths? Yes. So 12 is my denominator. And how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So looking at the lines, the only ones you can do are the ones where it separates right in between the 2 blocks. Looking at it mathematically, the ones you're going to be able to do are the ones that you multiply the denominator by something to get the new denominator. So 4 times 2 is 8, 4 times 3 is 12, 4 times 4 would be 16, so that would be the next one in the chart that would work. Okay, so that would be 12/16. That's why the ones in between don't work. Okay, this page right here, toytheater.com/fraction-strips/ is where this screen comes from. Okay, what you do, this is just a screenshot from that page. So you can go over and play with it, and it is fraction strips just like on that other page. If you notice, the colors are pretty similar too. But what you would do is you would take this one and you would drag it up to where you wanted it. Or you take this one, click on it, and drag it up to where you wanted it. So you can just play around and see which fractions are equal to which other fractions. Okay? If I have time, I can make another video on using that, but for right now, whoops, I didn't mean to erase, there you go, the URL. For now, just go play with it or skip it if you'd like. Okay, we're moving on. Okay, these are in your notes. So this first image is the 1/5, and the second image is the 2/5. Okay, and we're going to say there's 1 out of 5 shaded in. So 1 shaded, 5 possible squares, so 1 out of 5. This is 2 out of 5. That's how they come up with what they were doing. Okay, and when you add them up, okay, you take the blue ones, which there are just one there. Whoops, sorry, there is just one. And you take the red ones, and there are 2. So how many total are there? 3. And it's out of 5. So it's 3 out of 5, or 3/5. Okay, so the bottom one, same thing. We have 4 blue ones, so we're going to add 4 over here. 2, 3, 4. And we have 2 red ones, so 1, 2. And we have a total of 6 shaded, so it becomes 6 over 7. 6 out of 7. Okay, and I'm going to zoom in on the problem we had over here. So you can see from the original problem, and we know the answer is 6 over 7. You can see how they got it. 4 add 2 is 6. And then the 7 stayed 7. This comes from the fact that the 7 denominator just tells you how many pieces there are in 1. Okay, so sevenths plus sevenths is going to equal sevenths. If you get different numbers, then it gets much more tricky, and that's a little bit later in this section. Okay, so here is the rule. Okay, and the rule is a little crazy because they've used variables instead of numbers. So let me break it down for you. You notice that when you add a number over C to another number over C, you get something over C. The denominator, in this case the C, doesn't change. C represents any number, and as long as that number stays the same, you're fine. Now A and B also represent numbers, but they are different numbers in this case. Okay, so the A comes over, and you're adding the B. Okay, so you're basically doing A add B goes on the top. Okay, for example, the 9s have to be the same in order to add them up. And they are, so the answer is going to stay over 9. And then you just add the 2 and the 5 for a total of 7. And you're done. That's it. Okay, because you're only adding pieces of a rectangle together. Okay, so this rectangle, square, whatever, has 9 parts. So that's why it's out of 9. I started with 2. And now I'm going to add 5 more, right? So 1, 2, 3, 4, 5. So how many total are shaded? 7. And that's where they came from. Okay, so back up to here. Okay, I had to move that off to the side. So The top part of a fraction, this is a very long stretched out fraction, is how many you're talking about. So in this case, the 7 colored ones, over how many parts there are in one square. And there are 9 individual parts inside the square. Okay, so another way to think about it is what is $2 plus $3? It's $5, right? What is 2 classes plus 3 classes? 5 classes. 2 apples plus 3 apples? 5 apples. What is 2/6 plus 3/6? It is 5/6. Okay, it's like the sixth is your label. It's whatever you're adding up. It's the things that you're talking about. Okay, moving on. Okay, here you can see they've done theirs. I'm going to move over and do ours. You can look at theirs however and whenever you want, okay? All right, so ours, we see that the denominators are both the same, so that's good. That means the answer will have the denominators. It's exactly the same. So I have 5 of these things plus 3 more of these things. So I have a total of 8 of these things. Okay? All right, so you just add across the top and you keep the bottom. Okay, so with that in mind, across the bottom on the second problem here, we're going to leave the 35. Now across the top, we're going to add 12 and 2 and get 14. Okay, the only difference with this one and the 8/11 one is 14/35 can reduce. It can simplify because 7 goes into both 14 and 35. Okay, so then the 7's cancel, and the final fraction answer is 5. Try again, 2/5. Okay, so what that means, like at the very beginning when we had all of those fraction strips, right? And this was halves, and this one was thirds, etc., all the way down. If I went down far enough to get to 35, and I drew a line at 14 of them, that line would also be the same thing as 2/5. That's all the equivalent fractions mean, okay? Okay, here's the next part. And you can see they've done a couple, so let's do ours. We have a weird one that they didn't cover anyway, so here we go. The 4 stays the same, right? So I have 3 of these things, and I'm going to add 1 of these things for a total of 4 of those things. A number divided by itself is 1. Okay? So you have to simplify things as far as you can every time. Okay, the bottom one. The 9's are going to stay as a 9 in your answer. So now I have 1 of them, add 2 of them for a total of 3 of them. But now 3 and 9 both divide by 3, right? So we're going to go 3 stays on the top. 9 is 3 times 3. A 3 cancels top and bottom. So now you're just left with the 3 on the bottom. Since the 1 completely, or the top completely canceled out, you need to leave a 1. Because the same reason up here, as 4 divided by 4 is 1, 3 divided by 3 right here, this is 1. So there's that 1 right there. Okay, this one that they did is a little crazy. I wouldn't go quite this far, but you can. Okay, let's do ours, and then we'll do the hard one next. Okay, so I have 4 of these things plus 5 of these things. 4 plus 5 is 9. and those things happen to be a 3, or thirds. 9 divided by 3 is 3. So that's your answer. This is a fraction bar, and it's also a divide bar at the same time. So you can do 9 divided by 3 equals 3. I didn't think my dog would stay asleep the entire time, but yep, he's awake. Okay, this one. They're both 96 denominators, so we're going to keep the 96. Now we have 87 add 75, and we get 12, carry 1, 15 plus 1 is 16, 162. That's a huge number compared to regular fractions. So now you use the divisibility rules that we've learned in the past and break it down. Okay, I know that both of them are divisible by 2, so I'm going to start there. I'm going to do a 2 times something on the top and 2 times something on the bottom. If you can't do it in your head, then off to the side, do a division problem. Okay, so 81 on the top, and, oh, that was cute, 48 on the bottom, and the 2's cancel. Okay, but now 81 and 48 both divide by 3, because 8 plus 1 is 9, which divides by 3, and 4 plus 8 is 12, which divides by 3. Okay, I'm going to finish this problem and then go see what he needs. Okay, so 3 goes into both. 81 divided by 3 goes in 27 times. And 48 divided by 3, 16 times. And the 3's cancel. Now 27 and 16. 27 is 3 times 9, and 9 is 3 times 3, so it's just a bunch of 3's. And none of these 3's go into 16, so you're done. This is your answer, 27 over 16. And you can change it to a mixed number if you would like to. If you do that, it looks like this. So your answer is 1, and then the remainder comes up over the denominator that doesn't change, 1 and 11/16. Yeah, make certain you have scratch paper handy on some of these, right? Okay, on this page, I just lift up what we were talking about so I can not have to write it all again, but let's take a look at this. Okay, so what they want you to do is write 5/8 as a sum of fractions in 2 different ways. They did it twice, and I did it another time after that. What you notice is all of the denominators stayed the same, but the tops have to add up to 5. So 2 add 3 is 5. 4 add 1 is 5. We could have done 2 add 2 add 1 is 5, right? So now you just need to put them over 8. Now that equals 5/8. Okay, and here what we did in class was 7/9. So we had 7 ones added up, give you 7. 1 add 6, 3 add 4, 2 add 3 add 2. You know, you've got other options too. You just want to leave the denominator the same and add the top numbers up to give you the number they were looking for. Okay, now here it's the same thing, except you have a whole number in the front too that you can also break up. Okay, so 3 ones give you the 3. And 1 plus 1, both over 3, give you 2. 1 plus 1 is 2 over 3. Or you could leave the 3 as a 3 and then add the 2 fractions. Or you could break up the 3 and leave the fractions together. There's so many different possibilities. Okay, so over on this side, we had 2 and 2/5. Okay, so here's your 2. And then 1/5 plus another fifth is 2/5. So now here you have 2 plus 1 is your 2/5. 1 plus 1 is 2 and 2/5. Now here's getting really complicated, but we could go 2 times 5, or 5 times 2 is 10, add 2 is 12. So this is equal to 12/5. So 3, add 3, add 3, add 3 is 12. And 12/5 is 2 and 2/5. So that would be acceptable. However, these three are much easier, right? Okay. Okay, on these two, you are checking all that apply. So I'm going to check the ones that do and leave the ones that don't blank. I'm not certain. Let's see what I do. Okay, here we go. I'm going to draw out 2 and 1/3 so that you can see what we're talking about and refer to it as we go. Okay, so in this particular situation, we would have all of this one, so there's 1, all of this one, so there's 2, and then 1 out of 3 parts. So this is equal to the 2 and 1/3 they were talking about. Okay, so now is 2 times 1/3 equal to this? No, it is not. This means I have 2 of these, which would be equivalent to or equal to repeated addition, those two added up. So it would only have those two, and these two wouldn't even be included. Okay, so that one's no. And let's leave that part in there. Maybe. Yeah, let's leave that part in there. There we go. Okay, so I'm just going to say no. That'll be easier. Okay, so this next one. If I have one whole one plus another whole one plus a third of a one, isn't that what we just drew? 1 plus 1 plus 1 out of 3. So that one is yes. All right, so the next one. I start with 2 whole rectangles and I subtract a third of one. That is not true because here is one rectangle, here is a second rectangle. Whoa! Technical difficulties there, I'm sorry. Okay, so I start with 2 and I want to take off a third of one, which means I'm going to take that off. And that's not what I had, is it? So that one's also no. Okay, so the top one, if I start with 2 and I add 1/3 to it, here's my 2, and I'm going to add 1/3 to it. That one's fine. And 1 times 1 times 1/3. Okay, 1 times anything is the other number. 1 times 5 is 5. 1 times 3 is 3. 1 times 57 is 57. So 1 times 1 is 1. So 1 times 1/3 would be 1/3, not 2 1/3. So that one is wrong. So none of these is also wrong because I got 2 yeses. Okay, this side. And again, I'm going to draw it out. I'm going to draw a rectangle and then shade in 4 out of 5. Okay, so there's my rectangle. And there's 1, 2, 3, and 4 of the 5 parts are shaded. Okay, so the blue part represents 4/5. So is that 4 times 1/5? Yes, it is. Okay, because this means repeated addition. I have 4 1/5 added up. So that one's yes. Okay, and it looks just like this. 4 1/5 added up. Okay, next one. If I take the whole rectangle, one of them, and I take away 1/5, do I get the blue stuff? Sure you do. because you have the whole thing, and we're going to take this one off. And what we have left is the blue part. So that one is also yes. Okay, top of the next column. For add 1/5. This would be like 4 entire rectangles, great big ones, and then 1/5 of another one. So that is not what we're talking about. Okay, that would have 4 entire rectangles. Pretend these are rectangles. And then just 1/5 of the last one. Okay, so whoops. This is, yeah, you get the idea. Okay. Okay, on this last one, it's also wrong because notice the 3 and the 2 are not the same. You cannot add 3s to thirds to halves and get fifths. Okay, so for example, let me go back to the other screen. Hang on. 1/3 plus 3 halves. Okay, so here we are. 1/3 plus 3 halves means you have one of these orange ones and 3 of these red ones. 2 of them already make 1, so a third one would be out here, and then you have the orange part tacked on the end. So it's this long. It's not equal to 4/5, which is just this part, right? So this one is also no. So I'm going to write in here, not the same. So is that to say you can't add fractions that don't have the same denominators? No, that's not what we're saying. It's just you don't do it this way. You don't do it by adding straight across. Okay, so there's those. All right, now here's what's going to happen when we're adding fractions with different denominators. Okay, so one-third plus 1/4. Here we go. Okay, so back here, 1/3 plus 1/4. I want to add one of these orange ones to one of these yellow ones. The idea, though, is I want the answer to be one color. So what does that mean? It means that I can't have thirds and fourths added up. I need to convert 1/3 to something and convert 1/4 to the same thing so that the two denominators are the same, so I can add straight across. Okay, so for example, now this is not the same problem, this is something different, but if the 5s are both the same, then they carry across to the answer and stay fifths. So 2/5 plus 1/5 is 3/5. Okay, the answer is just green, fifths. Okay, so now my dilemma up top is I have two different colors. I have thirds and I have fourths. I can't do that. So here we go. Okay, so I have outlined the 1/3. There's its box. Okay, and I have outlined the 1/4, and there's its box. So now I want to combine those together. I'm going to move this up here. I'm going to have to slide the screen over a little bit. And I want to figure out where I can put these so that it ends right on the line. Here it's not quite right? Because it doesn't fit on that line and this line, so that doesn't work. 6 doesn't work. 8s don't work. 10s don't work. But 12s do. Okay, so if I change the orange one into 4/12 and I change the yellow one to 3/12, then I add them together, I will get 7/12, which is exactly what I want because that's exactly where they end right here. 1, 2, 3, 4, 5, 6, 7, 12. Okay, so that wasn't too bad using my chart and my iPad abilities, but how do you do it mathematically? Okay, whoops, wrong button. If you notice, 3 and 4 both divide evenly into 12. Okay, so 12 is considered a least common multiple of the denominators. In other words, a least common denominator, LCD. Okay, in this case, you just times them together, but that won't always be the easiest way. Okay, and I'll show you some ways of doing it. Okay, so I convert 12 or 1/3 to 12ths by timesing by 4. So if I times by 4 on the bottom, I times by 4 on the top. 4/12ths, which is what I just got. What do I times 4 by to get 12? 3. If I times on the bottom by 3, I times on the top by 3. Denominator's 12, numerator's 3. Okay, so now let's go back to the other page. Okay, so we did this one. I'm not going to do these other two. I'm just going to point a couple things out. Okay, you cannot add straight across because the 3 is different than the 2. You have to get them to be the same denominator. So what number do both 3 and 2 go into evenly? 6. You can times 3 by 2 and you can times 2 by 3. And if you times the denominator, you have to times the numerator. Okay, and that's going to be our process here in just a little bit. Okay, on the bottom one, what do 5 and 2 both go into evenly? 10. And you get here, times them by each other. You do 5 times 2, and you do 2 times 5, and it works. Every single time it'll work. But sometimes it's not the easiest. Okay? We cannot add straight across unless the denominators are the same, and they're not. Because we're adding the same size, we need to add the same size pieces. So you've got to change them, like we had to change 1/3 to 12ths and change 1/4 to 12ths so that we could add the 12ths because they're all the same. Okay, I said that sometimes that's not the easiest way. That's absolutely right. And that's this page is what I'm going to show you. All right, if I just multiply them together, I would get 6 times 4 would be 24. And it would work. It would definitely work. However, there is a smaller number that they both go into, and that is 12. I would prefer to work with smaller numbers than bigger numbers, so I want to find the 12 personally. If you don't want to work at finding the 12 and you don't mind using the 24, it will be fine. The difference is you have to simplify at the end that you sometimes don't have to do if you use the smaller numbers. Okay? Another possibility here is if the small number goes into the big number is what you want to use. So I'm going to leave 5/12 and I'm going to change 1/3 to 12ths because I can. I can times by 4. And I'm going to stop there on that one. We're not going to finish these. Okay, on this one, 2 goes into 8. So if I times by 4, I'll get 8s on the bottom of both of those. Okay, that's your goal, is to get denominators to be the same. And it doesn't have to be the smallest same number. It just has to be the same. Now this section looks like it slid sideways. This section is where we're going to find the least common denominator. And they say least common. That means the smallest one. And I'll show you later how to do it with the not so smallest one, so you don't have to worry about that. But this section is finding the smallest. Okay? And we're going to use least common multiples to get there. So let's just do a quick reminder of how to find them. Okay, let's say 24 and 18 are the numbers that I want to find the least common multiple of. So it's the smallest number that these two numbers divide evenly into. Okay, which means I want to be able to times 24 by something and 18 by something else and get the same number. Okay, this number will be the same. So how did we do before? How did we do that before? Here. And apparently I keep hitting the wrong button, so sorry about that. All right, so we want to see what number goes into both 24 and 18. If you get 6 the first time, that's great. But I'm not going to use 6 this time. I'm going to start with 2. So 2 goes into both of them. So I circle it. 24 is 2 times 12. 18 is 2 times 9. Okay. Now, 12 and 9 have a 3 in common. And I circle it. So I only circle the in common numbers. 12 is 3 times 4. 9 is 3 times 3. Okay, I can break 4 down. But if I do, I can't circle anything between here and here. So I didn't need to do this. So if you can recognize here that 4 and 3 don't have anything in common, you're done. Okay, so now we want to look between these two numbers and see what they had in common. Okay, they each had a 2. So I'm going to bring 1, 2 down for my answer. And they each had a 3. So they have a 3 in common. I'm going to bring 1, 3 down for my answer. But now they also have a 4 on this side and a 3 on this side that I'm going to multiply by after I find my common ones. Multiply all of this up, and that is your common denominator. So the circled numbers, 2 times 3 is 6. The non-circled numbers, 3 times 4 is 12. 6 times 12 is 72. So that's your least common multiple of those two numbers. Okay, so that's the reminder of how to find it. So we're going to be doing this process with denominators now. Sometimes you can do it without this, and you can do it in your head, but I'll show you this as often as I can to show you where it's coming from. Okay, now they do it their way, which makes sense, but what I showed you on that last screen is not that way. Okay, all right, so let's look at these two. I don't care about the 1 and the 3. All I care about is the 10 and the 4, because those are the denominators. I want to find the least common denominator. It has nothing to do with the numerators. Okay, so I'm going to take a 10 over here and a 4 over here, and I'm going to break them down. 10 and 4 each have a 2 in them, right? So I'm going to include a 2 right from the beginning. And now see what's missing. So 2 times 5, right? And 2 times 2. Okay, so the least common multiple of the denominators is what we're looking for. Okay, so the least common multiple of the denominators. So I need the 2 that I circled. It comes down because it's in common. So this is this 2, And this is this 2. You don't bring down 2, you bring down 1. Then I bring down the 5 from the red part and the 2 from the blue part that are not circled. When I multiply those, I get 2 times 5 is 10. 10 times 2 is 20. So 20 is my least common denominator, and that's all I need. I'm done. And that's what the directions say. It says find the least common denominator. And because it says least common denominator, I need the smallest one. So I need to do the least common multiple of the denominators. Okay, I'm going to do the second one on this screen this way, and then I'll show you a different way. Okay, so I have a 25 as my first denominator, so it comes over here. And I have a 20 as my second denominator, so it also comes over here. What do they each have in common? A 5, right? 25 is 5 times 5, and 20 is 5 times 4. Okay, you can break the 4 down to a 2 and a 2, but you can't break the 5 down, and they have nothing in common. So we don't need to go any farther on those two. We're done. Okay, so these two 5s come out as a single 5. Now the extras come down, so timesing by a 5 and timesing by a 4. Okay, in this case, I'm going to multiply these two first and get 20. 20 times 5 is 100. Remember, when you're multiplying, you can do them in any order because of the commutative and associative properties. Okay, so 100 is my least common multiple of the denominators, or my LCD. Okay, now I told you I'd show you a different way. Look at the biggest number of the two denominators, so 10. 4 does not go into 10, right? So 10 is not it. I'm going to do, this is 1 times 10. What's 2 times 10? It's 20. Does 4 go into 20? Yes. So that's my answer. Will that work every time? Yes. Will it be easy every time? No. Okay. So here we go. Our biggest number on the bottom is the 25. 20 does not go into 25, so that doesn't work. So 25 times 2 is 50. Does 20 go into 50? No, that doesn't work. 25 times 3 is 75. Does 20 go into 75? Nope, that doesn't work. 25 times 4 is 100. Does 20 go into 100? Yes, so that's it. Sometimes that green stuff is easier for your brain to do in your head. And if that makes sense to you, go ahead and use it. If I just totally lost you, don't worry about it. You can ask me in person, but that's all right. You don't have to do it. Now we get to find the least common denominator and rewrite equivalent fractions with that denominator. Okay, they have one here that you can look at. And of course, ours is harder. Great. Okay, so I'm going to put the 15 over here, break it down, the 24 over here, and break it down. And what do they have in common? 3. 15 is 3 times 5. 24 is 3 times 8. So the 3 is in common. I circle it. Now I'm looking at the 5 and the 8, and they don't have anything in common. You can break the 8 down, but it doesn't go into the 5. Okay, so least common multiple of the denominators, is the circled 3, then the extra red 5, and the extra blue 8. Multiply those up. I'm going to do 5 times 8 first, which is 40, and then 40 times 3 is 120. Okay, whew, All right, so now I come back over here and I'm going to rewrite 3/15 out of 120 and 7/24 out of 120. Okay, so here we go. I'm looking at 15 first. I want to find a number that I times 15 by to get 120. When I find that number, I'll also times the top by it. Whatever you times by on the bottom, you have to times by on the top. Okay, so now I look over here. All right, I know I got 120 by multiplying these three numbers. The 3 and the 5 are the 15, which is what I'm talking about. Okay, so 15 is 3 times 5. So I find the 3 and the 5. Okay, so here's my 3, here's my 5. What's missing? The 8. Okay, I already have a 3 and a 5, so I need the 8 because 3 times 5 times 8 is 3 times 5 times 8 gave me the 120. So I have the two red numbers here. I'm missing this one. So I have to times by this one. So I'm going to times by 8 here and here. So 8 times 3 is 24. I'm done with that fraction now. Now the other fraction. I want to know what to times by top and bottom here in order to end up with 120. So I look over at my blue part, and I know that it broke down into 3 times 8. 3 is here, 8 is here. It doesn't have a 5. So I could times by a 5 over here because 24 times 5 is 120. But I don't need this because I have this. I know that I times 3, 5, and 8 to get 120. And I already had the 3 and the 8, so I was missing the 5. 7 times 5 is 35. Now I'm done. Okay, let's do another one. All right, 7/18 and 5/21. You don't have another one, so I had to make one up. All right, so 18 first, break it down, and 21 and break it down. And notice I don't start breaking them down yet because I want to break them down into something they have in common. 18 and 21 both divide by 3. Okay, so I'm going to circle the 3 because it's going to be in common. Circle this 3 because it's going to be in common. 18 is 3 times 6, 21 is 3 times 7. Okay, so the least common multiple of the denominators is the 3, then the extra 6, and the extra 7. Okay, this one's not too easy to do in your head, so I'm going to do a little bit off to the side here. So 3 times 6 is 18, and 18 times 7 is 126. Okay, so that's my final answer. Now I come back over here, and I'm going to rewrite both of these fractions as 126s. All right, so 18 is over here, and it was 3 times 6. So now I'm looking at the 3 and the 6. Okay, 7 was not included. So I'm going to include it by timesing my fraction by a 7. On the top, I get 7 times 7 is 49. And on the bottom, when I multiply these two, 18 times 7, as you can see right here, is 126. Okay, now let's do the 21. 21 is, whoa, sorry about that. 21 is 3 times 7, which is here and here. It's missing the 6. Okay, so I find the denominator I'm working with, so 21, and when I break it down, I got 3 times 7. So I already have a 3 and a 7 in my 21. I don't have the 6, so I'm going to times by the 6, top and bottom. Across the top, I get 5 times 6, which is 30, and across the bottom, I get 21 times 6, and I'll show you, it is 126. So you're done. Okay, so now we're going to actually add the fractions and then simplify. Okay, gotta love it when I forget to erase. All right, so I'm going to show you 2 different ways on this one, just so you can see something. All right, I need to find the least common multiple of the denominators, 6 and 4. Okay, so you can break them up. You can do 6 and 4. 6 and 4 both have a 2. So it's 6 times 3, 2 times 2. So it's 2 times 3 times 2, which is 12, right? So the least common multiple of the denominators is 12. So now I'm going to change both fractions to 12s. So 6 is 2 times 3. It's missing a 2. So I'm going to times by 2, top and bottom, because I want to get a 12. 6 times 2 is 12 now, right? So 2 times 1 is 2. That's going to go on the top. Okay, now 4 is 2 and 2. It's missing the 3. So I'm going to times by 3, so that denominator is now 12. 3 times 3 is, okay, so now the 2 twelfths plus 9 twelfths straight across is 11 twelfths. Okay, so you find a common denominator, which is 12. Change your numerators, and then add them across. Okay, now I said I'd show you a couple ways. Let me do one more this way, and then I'll show you. Okay, so let's take a look at this one. So 18 and 28, I'm going to pull them off to the side. 18, 28. What do they have in common? A 2, right? So this is 2 times 9, and this is 2 times 14. 9 and 14 don't have anything in common. So the least common multiple of the denominators is that. These 2 is 18. So 18 times 14 is 252. Okay. All right, so I'm going to change 18 to 252, and I'm going to change 28 to 252. All right, 18 is here, which is 2 times 9. So here's the 2 and the 9 that make the 18. It's missing the 14. So I'm going to times by 14, top and bottom. Okay, so 14 times 5 is 70. Okay, 28 is here, which is 2 times 14, which is here. It's missing the 9. So I times by 9. I get 27. Add straight across the top. You get 97 over 252. And I don't believe that simplifies. We're just going to say it doesn't. Okay. Now I told you I'd show you a different one. So let me rewrite this first problem. Okay, so here it is off to the side. Okay, back at the beginning of all of this, I told you that you could multiply these two numbers together and it would always work. Okay, so that's what I want to show you. I want it times 4 by 6 and 6 by 4. Okay, so times by 4 top and bottom, times by 6 top and bottom. And let's see what we get. We get 4 over 24 plus 18 over 24. Okay, they're both 24s, so we can add straight across and we get 22 over 24. 2 goes into both of those, right? So this is 2 times 11 and this is 2 times 12, and the 2's cancel. So you're left with 11 over 12, which is exactly the same thing. Okay, so in this case, it was pretty easy either way. Well, comparatively. Look at this one, however. Would I want to times 18 by 28 and 28 by 18? That would be horrible. I wouldn't choose that method on this one. Okay? All right, there's that. All righty. Let's look at ours. Here we go, 20 and 15. Okay, I'm going to do this one just slightly different because remember, this is 20 times 1. 15 doesn't go into it. 20 times 2 is 40. 15 doesn't go into it. 20 times 3 is 60, and 15 does go into it. So I'm going to change everything to 60ths. Okay. If you can do it without doing those little chart things over here, go ahead, you know. So that's what I'm going to do on this one to show you. Alrighty, so what do I times 20 by to get to 60? And I need to times by 3. If I times the bottom by 3, I times the top by 3, and I get 18. What do I times 15 by to get to 60? And it's 4. So if I times the top by 4, or bottom by 4, I times the top by 4. So I get 8. Multiply straight across, I get 26 over 60. And now they both have a 2 in them. 26 is 2 times 13. 60 is 2 times 30. 2's cancel. So we have 13 over 30 is the final answer. Okay, so sometimes this stuff over here isn't necessary. Sometimes it's incredibly helpful. And I'm going to use it on this one because 15s and 24s are kind of awkward numbers, so I don't want to do what I did on that top one. Alright, so here is my least common multiple of the denominators. This is 40. 40 times 3 is 120. Alright, so I'm going to change both of these to 120s. And what do I times 15 by? 15 is a 3 and a 5, which is the 3 and the 5. It's missing the 8, so I times by 8, top and bottom. What do I multiply 24 by? 24 is 3 times 8, so here's the 3, here's the 8. It's missing the 5. So I times by 5, top and bottom, and I get 25. Add straight across now, and I get 56. 7 over 120. And those each divide by 3. 57 is 3 times 19. 120 is 3 times 40. And the 3's cancel. So I'm left with 19 over 40. There we go. Okay, now this screen is not in your notes, and I've already talked about it, but if you don't find the least common denominator and you just use a common denominator, it still works, but you'll have to reduce the answer. Okay, so between 6 and 9, the common denominator, try it again, the least common multiple of the denominators is 18. However, we'll get the same answer if I used 54 instead. I got 54 by multiplying these two by each other. Okay, so I'm going to times 9 by 6, and I would get 12 over 54. And I'm going to multiply 1/6, top and bottom, by 9, and I would get 9 over 54. So this becomes, shrink it down a little, 21 over 54. Okay, and you can see this is a little bit harder because the numbers are bigger, but it still works. 3's cancel, and we end up with 7/18, which is what we started with over on this other side. Okay, but the numbers got bigger. Yeah, I'm dealing with 54s. That's not a normal number to break down, right? I just happen to know that it was 3 times 18. You may not know that. So trying to get the smallest number for a denominator is the easiest way in general. Okay? Okay, these next two, I'm just going to put this up on the screen, already done. We've gone over quite a few of these already. So let me explain one thing on this page that I haven't talked about yet. Okay, simplify to lowest terms. Lowest terms can be improper. As long as you can't break it down and cancel the same thing, top and bottom, you're done. So as long as nothing that divides into both 41 and 36, you're done. So for example, if I had 18 over 12, I would not be done because 18 is 6 times 3, and 12 is 6 times 2, and the 6's cancel. But 3 over 2, now I'm done. Lowest terms does not have to be a mixed number. It didn't say that. Okay? So both of these answers are completely acceptable as is because they're both completely simplified. And same thing here. Okay, the 23 over 18 is completely simplified. On this one, it's completely simplified, and it doesn't matter that the top is bigger because it isn't. Top is smaller than the bottom. Now these two problems have 3 fractions. Doesn't change the process, it just sometimes makes finding the common denominator a little bit harder. This one, however, isn't too bad because 8 goes into 16 and 4 goes into 16. So we're going to use, 16. Okay, so I'm going to rewrite all of these fractions as 16ths, which means the first one's done. 8 I have to times by 2, so I times 1 by 2 as well, and I get 2. 4 I have to times by 4, so I times 3 by 4 as well, and I get 12. Now you add straight across, and we get 5 plus 12, 17 over 16. See, not bad at all. Okay, this one, a little bit harder because 3 goes into 15, and 3 goes into 6, but 6 does not go into 15. Okay, So I'm going to double 15 and I get 30. 3 goes into 30 and 6 goes into 30. So 30 is our common denominator. Okay, so change it to 30s, change it to 30s, and change it to 30s. So the first one I times by 2, top and bottom, and I get 6. Second one I times by 10, top and bottom, and I get 10. Third one I times by 5, top and bottom, and I get 25. Okay, 6 plus 10 plus 25 is 41. So my final answer is 41 over 30. And you can leave it because you can't simplify it anymore. Okay, and the last two, I apologize, but I don't have the originals on this one. I had to handwrite them. These are the easiest ones in the entire assignment. 3 plus 5/9 is 3 and 5/9. That's it. You're done. And following along over here, 1 plus 2/3 is 1 and 2/3. Okay? To me, that's absolutely ridiculous. So, but it's important to know, so we're going to throw them in. All right, that was an incredibly long video, and I apologize, but it covers everything. So now you can refer back to this anytime you need to, forward, go backwards, find the place you need, whatever. Okay? All right, let me know if you have any questions.